This exercise is about checking the validity of a formula. So a formula can be always true, so always true. It can be always false, so always true, always false, and then sometimes true and sometimes false. In the first case, we say that the formula is a tautology, or that it is a valid formula. In the second case, we say that it is a contradiction. And in the third case, we say that it is neither. It is neither a tautology nor a contradiction. So these are the three types of formula that you can have: always true, always false, and sometimes true, sometimes false. Tautology, contradiction, or neither. So consider the following formula. P implies Q implies P. All right? So is this formula a tautology, a contradiction, or neither? That's what we need to check. Now, the first thing to do is to write down all the possible combinations of valuations, of zeros and ones that we can assign to the atomic formulas. So in this case, we only have two atomic formulas, P and Q. So you write them here, and here you write down so all the possible combinations. We only have four because we have two atomic formulas in total. So we can have that they both can take value 1, or one take value 1 and the other take value 0, or they both take value 0. So a total of 4 combinations. Now, once we have all the combinations for the atomic formula, let's go one step more complex. And so let's look at P implies P. Now you can see that P implies P is always going to be true, because the antecedent and the consequent, the P on the left-hand side of the arrow and the P on the right-hand side of the arrow, are always going to have the same truth value, right? So it's going to be 1, 1. So this means that this whole formula will have value 0. Value 1, because both P here and P here get value 1. And then it's going to be 1 again, because the P here gets value 0 in this case, and gets value 0 again. And so the whole implication has value 1. So, now, what about Q implies P? Well, Q implies P. Now, if Q has value 1, and then P has value 1, then the whole implication has value 1. If Q has value 0, so this is the case in which Q has value 0, and then P has value 1, then Q implies P has value 1 again. If Q has value 1, but P has value 0, this is we're here, then Q implies P has value 0, because Q has value 1, P has value 0, therefore the whole implication should have value 0. And then both of them have value 0, therefore the whole implication has value 1. Okay. So the next thing we need to do, we need to consider the whole formula. So P implies P, and then implies Q implies P. So we have that P implies P as value 1, and then the Q implies P as value 1 as well. So the whole formula here should have value 1. Now next line, we have that P implies P as value 1. We have that Q implies P as value 1, and so the whole formula has value 1. Now here we have that P implies P as value 1, and that Q implies P as value 0, so this whole formula has value 0. And then finally we have that P implies P as value 1, and that Q implies P as value 1, so the whole formula has value 1. Now we can see that this formula here is not always true, is not always false, but it is sometimes true and sometimes false. So the answer here is that this formula is neither. And we are done.